Hey everyone, welcome into this lecture on derivatives of the Arc-Trig functions. In this lecture, I'm going to compute the derivatives of two of the Arc-Trig functions and leave the rest of them as exercises for you, but they're all going to be done in generally the same way. So I'm going to do these ones for you guys or with you guys. You please work together with me here. Let's start with the arc sine function. So let's suppose we have the function y equals arc sine of x. And we want to know what's the derivative of this function. So can we find a formula for the derivative of this function? So in other words, we want to know, can we compute the derivative d by dx of arc sine of x? So we have a really good intuition about what this function means geometrically from the unit circle. And we discussed that in the last lecture video, so please watch that if you haven't yet. In this video, we're just going to assume that we know the geometry of this and just try to compute a formula for this, right? So first of all, what does it mean in a calculus sense or a function sense for y to be the arc sine of x? Well, it means that it's the inverse function of sine, right? And so this is only true if the sine of y is equal to x. This is one of the definitions of an inverse function. And we went to a lot of pain to restrict the y values so that this equation would in fact be true, right? Whenever y is in the range or the codomain that we restricted to or co-restricted to. So we can write this, right? This is true. And this is better because we know how to compute the derivative of the sine function, right? So at this point, what do? We're going to apply the derivative, d by dx, implicitly to the entire equation, right? And so what do we end up with? We end up with the derivative, d by dx, of this equation, sine of y equals x. The derivative is linear, and part of linear is that it can distribute over this equal sign. So it's going to be applied to this, d by dx of sine of y is going to be equal to derivative of x with respect to x. That's just 1, right? Now, I didn't take the derivative of this one on the left-hand side because we need to be very careful with it. This is the sine of y, but the derivative is with respect to x. Y is itself a function of x, right? It's a function of x. So we are very carefully going to take this derivative. So the derivative of sine we know is cosine. So this is cosine of y. But by the chain rule, we have to multiply by the derivative of the inside. So multiply by dy dx. And it still equals 1 on the right-hand side. And now we can solve for our derivative. This is what we want, right? Remember, this function, arc sine, this is our y. So when we see dy dx, we see the object that we are trying to compute right here, right? So now we can rearrange and solve for this. dy by dx is equal to 1 over cosine of y. But we can't leave it this way because the variable y is the function that we started with, right? So we can't start with that. We have to now try to figure out a way to eliminate this y and get it back in terms of x. And to do that, we can look at this equation, right? So this one says that sine of y is equal to x. Well, from the right triangle trig definitions, right, we can think of this as sine of n angle equals x over 1. Sine of n angle equals opposite over hypotenuse. So we can draw a triangle, draw a right triangle, and plug in the pieces, right? So number 1, the y value, that's the angle. So there's our angle right there. And then opposite over hypotenuse, where there's our hypotenuse. Our opposite side is x. And if we go back down here, what we now want to know is what's the cosine of y? Well, that's the same angle y, right? The cosine is the adjacent over hypotenuse. And so we just have to apply a Pythagorean theorem here. And this is going to be 1 squared minus x squared square root. And so what we end up with then is that the derivative is equal to 1 over cosine of y, well, that's square root of 1 minus x squared. All right, so at the end of the day here, we have computed using implicit differentiation and our knowledge of geometry that this derivative of arc sine of x is equal to 1 over the square root of 1 minus x squared. All right, and that's a formula that we can just remember. We don't need to compute it this way every single time. If we forget the answer, we have to compute it, but we can just use this, right? Now, the other one, I said I was going to compute 2 of these. The other one I'm going to compute is the one that's very closely related to this, right? So let's recall that sine of theta is equal to, in terms of the well, I'll write it in terms of right triangle trig because that's the way we've been doing it, right? So I tricked myself here. Opposite over hypotenuse, right? And the cosecant of theta is the reciprocal. So it's h over o. And we talked about in our last video, when we remember the definitions of the arc functions, that what this means then, right, is that the arc cosecant of x as a function of x is equal to the arc sine function of the reciprocal, 1 over x, right? And so obviously now what I want to do is take the derivative of the arc cosecant function. So let's compute it. Derivative with respect to x of inverse cosecant or arc cosecant of x. Well, what's it going to be? By the chain, well, just by identity, it's the derivative of this one. So d by dx of arc sine of 1 over x. And then by the chain rule, it's going to be the derivative. What are we going to do, right? So I'll label this for us. We're going to call this u, right? And so what's it going to be? It's going to be d by dx. If I call that u, then it's going to be d by du of arc sine of u, right, times du dx, derivative of u with respect to x. So let's write these down. Well, we know what the derivative of arc sine is. We just computed it, right? It's 1 over square root 1 minus x squared. Here we've got a u, so that's just going to make it a u squared, right? So we've got 1 over the square root of 1 minus u squared times the derivative of u with respect to x. U is this function, 1 over x. All right, derivative of 1 over x is negative 1 over x squared. All right, so this is all good. Now what we need to do, though, is put back in our u, right? So we need to plug back in, get everything in terms of x. This is now the square root 1 minus 1 over x quantity squared times negative 1 over x squared. And we want to simplify this a little bit, get it as simplified as we possibly can. So this is going to end up, we can get a common denominator here, and we can write this as 1 over square root x squared minus 1 over x squared. This is negative 1 over x squared. All right, and then square root of x squared, that can come out as an absolute value of x, right? So an absolute value of x. So let's do it. So this then becomes, and by the way, it's a reciprocal, right? So this simplifies to be absolute value of x over square root x squared minus 1 times negative 1 over x squared. All right, and now we want to cancel these two. So we have the absolute value of x, we have an x squared term. So when these cancel, this just leaves behind an x, and then we got a minus sign here. This just leaves behind a single x value. You can work that out. So just very carefully think about the different options of if x is negative, if x is positive, if x is 0, what happens here. But it turns out that this absolute value of x and this x squared, they'll cancel each other out. And so what we end up with then is what? Negative 1 over x times the square root, x squared minus 1. All right, and this then is the derivative of our arc cosecant function. So after all that work, using the chain rule, using the formula for the arc sine derivative that we just worked out, the derivative of arc cosecant of x is equal to negative 1 over x times the square root of x squared minus 1. Okay, so there's two of them. These are two of the 6 trig functions derivatives, arc functions derivatives. So arc sine is this one, arc cosecant is this one. I'm going to write down now the other 4, but you must be able to compute these yourself. All right, you must be able to compute. So I'm going to write them down just so you know the answers, but this is, you have to be able to do these, all right? So d by dx, derivative of arc cosine of x. This is actually equal to negative 1 over the square root of 1 minus x squared. So that's just the negative of arc sine's derivative. In turn, we then have the derivative of arc secant of x. And this one is going to just be the negative of the arc cosecant. So it's 1 over x times x squared minus 1. All right, and then there's 2 more. So the derivative with respect to x of the arctangent function. This is 1 over 1 plus x squared. and derivative with respect to x of the arc cotangent function, which we defined the same way we did with the arc secant and the arc cosecant. This one turns out to just be the negative of 1 over 1 plus x squared. All right, so like I said, make sure you can compute those ones by the same methods. The two on the left have to be done by applying the definition of the inverse function, using some right triangle trig and implicit differentiation. The two on the right-hand side, once you have formulas for these, so these are the formulas, but once you believe these, right, and you can work these out yourself, then the two on the right-hand side are done by chain rule, and then careful calculations from there. All right, so please make sure you can work those out, and I'll see you in the next video.